Hi everyone, welcome back to the Microsoft in 29 days series. So in case if you have not registered for the Microsoft in 29 days self-paced course, so you can find the course link in the description of this video. Once you register for the course, so you can click on the start course button and you can see that we have provided each and every day here. Let's say if we click on day 8, so what we will get is we'll get the recording of the two individual problems that we discuss. Apart from this, you will also get to see the problems, like 5 problems for each day, 2 that we do inside the class and 3 are given as homework. And when you solve these problems, so you can also get additional facility to see yourself on the leaderboard and you can track yourself that what is your progress among your peers. So let us discuss this problem. Reverse each word in a given string. So the problem basically says that we will be given a string and we need to reverse each word in it where the words are separated by dots. So let us first of all take this particular example and understand what they are actually trying to say. So if we will look at this example, so the example is like I dot like dot this dot program dot very dot much. So what we have to do here is we basically have to reverse each word. So I is a single word, so not reversing it. Then like we will reverse, so E K I L. Then this word will also reverse, so T I H T. Then program will also get reversed, so M A R G O R T. That will be there. Then for very Y will be there, then R, then E, then Y. Then for much we will have H C U M. That is how we will reverse. So is there any data structure that we know that can help us to reverse? Yes, the data structure that we can use is stacks. Because let's say if I have a word, let's say I have a word like geeks. So if I have a word like geeks, if I put this word one by one inside a stack, so let's first of all I'll put G, then I'll put E, then I'll put E, then I'll put K, then I'll put S. After this, when I take this words one by one, I take the characters out. So it will be like S, then I'll pop out S, then I'll take out K, then I'll take out E, then I'll take out this E, then I'll take out G. So you can see my word is getting reversed. So stack uses the concept of last in first out, and because of this concept what happens is I can basically reverse the words or an array. So what I can do here is I can observe this part, that I can keep on pushing the characters one by one inside the stack until I reach the dot. The moment I reach a particular dot, so in that case what basically I can say is that I can take all those elements out and store it in an answer. Let's see how. So basically what I'm saying is inside my answer, first of all I'll mark it as null, and this is a single word, so it will be stored inside the stack. I will be stored inside the stack. Then I encounter a dot, so I'll take it out and store it in the answer. So I, and then after that I'll store a dot, because this was a single word, this was a single character, so we did not understood. But let's see for like. So first of all I'll insert L, then I'll insert I, then I'll insert K, then I'll insert E. Then the moment I see a dot, so at that point what I will do is I'll make the stack empty and I'll store all of the words inside the answer. So I'll say E, then K, then I, and then L. And after the stack is empty one by one, so what we will do is we'll simply store add a dot. And we need to see that for the last word, when the much is stored, when the last word is stored, after that we do not have a dot, so we will not be able to store this particular much in reverse order. It will be stored inside the stack, but how will we store it inside the answer? So for that, once we come out of the loop, so we can directly add it in our answer one by one. Okay, so that is what we can do with the help of stack. Let us try and implement this code using the stack approach. So for this, what we will be doing is we will be having a stack which will be consisting of the characters. Let's name it as st, and we'll be iterating like for int I starts from 0, I is less than s dot size. So we'll be iterating until the size of the string. Then we can do an I plus plus, and after this what we will be doing is we will say that if it happens, like I need to declare an answer string as well. So I'll say that string answer is equal to null, and then if the s of I, if the ith character is not equal to a dot, okay, so in that case I can keep on pushing it inside the stack. So I'll simply say that stack dot push nothing but s of I, keep on pushing the characters one by one inside the stack, and then else if this happens that the ith character is a dot. So in that case, what I will do is I will simply say that while the stack dot size is greater than 0, while the stack is having some elements, some characters inside it, so what we do is we keep on taking them out and store them inside our answer one by one. So we will simply say that answer plus is equal to st dot top, and then we keep on popping it out. So we do st dot pop, we pop out the characters one by one, and after this we can simply say that we need to add a dot as well. So we'll say that answer plus is equal to a dot as well. Okay, that is what we will be doing after we come out of the loop. So again we need to, like, one last word, that is much, will be stored inside the stack in reverse order. So what we need to do is we need to retrieve the much as well, because after much we do not have a dot, so that is why we would not be able to retrieve it. So if the stack size is greater than 0, right, while the stack size is greater than 0, till that point of time we need to do what, we need to say that answer plus is equal to nothing but st dot top, so that I can take the last word out in reverse format, and then I'll do st dot pop. That is what we will do. And then once this is done, so I do not need to add any dot for the last word, and I can simply return the answer. Let us try and see if this code works for the samples or not. Okay, so we are getting the exact same output. Let us submit this code. So you can see that our solution was able to pass all the test cases, right? But can we do it without a stack? Can we do it without using additional space? Yes, this question can also be done without using additional space by using the concept of a bit of pointers. So what we can instead do here is, let's say we have this word. So instead of using a stack, we can directly use the concept of reversing the segment of the stack. Let's say what I do is, if my I is standing here, okay, so what I do is I point my j is equal to I, and I move my I, like I will write that while the j is lesser than the string dot size, and j is s of j is not equal to a dot. Okay, till that point of time I keep on moving my j. So what will happen, my j will move here, then my j will move here, then my j will move here, then my j will move to this dot. So now once my j is pointing here, so you can observe that my I is still pointing here, and my j is pointing at a particular dot. So in this case, what I can do is I can say that j minus 1 is the position from starting from I till j minus 1 is the segment that I want to reverse. So basically I can reverse it by using by swapping the ith and the j minus 1th character. So basically, let's say if this range is x comma y, so I can swap the x character and the y character, then the character x plus 1 and the character y minus 1. Okay, like this. So I can basically swap the characters of the string. So that is another thing that we can do. So let us try and write the code for it as well. So we will say that string, like we will simply say that what we need to do is we need to start an iteration. So for int I starts from 0, I is lesser than the s dot size. Then here I'll not be updating the I, because the updation after this part is reverse, suppose. So I need to like, suppose j is pointing here. So now next time my I needs to point here. So for that I can simply say that I is equal to nothing but j plus 1. Okay, that is where it can point. So what we will do is we will say that int j is equal to nothing but I, and then while the j is lesser than the string dot size and the s of j is not equal to a dot, till that point of time we keep on moving our j pointer, j plus plus is what we do. And then once we are done with this, so we write a reverse function that will help us to reverse this segment starting from I till j. So string s comma j, like we need to reverse from this segment I to j minus 1. Okay, so we'll write a void function here. So void reversing this segment, and what we will write here is we'll write the string ampersand s, because I'm using C++, because so I'll pass it by reference so that the changes are reflected in it. Then I'll do int I, and I'll pass, let's say, int j as well. So what we will be doing here is we will simply say that we will run until while the I is lesser than the j. Till that point of time we'll keep on running, and what we will simply do is we'll swap nothing but s of I comma s of j. Will swap these two characters, and then once these two characters are swapped, we can also write the temp to swap these characters. Then I'll do I plus plus and j minus minus to swap I plus 1th character and the j minus 1th character. Okay, that is what we will be doing, and that is how the string would get reversed. And after this part is done, so we can simply return the string s. So let's try and like, after this part, another thing that we need to do is we need to update our I to nothing but j plus 1 as well. So let us try and compile this code as well. It also works on the samples. Let us try and submit this approach. This is without using extra space, because we are doing the operation on the string only and not using any extra stack. So this is how we can do this problem as well. Thank you. In this video, we will discuss the problem Candy Crush. The problem says that we'll be given a string s and will be given another integer k, and our task is to reduce the string by applying the following operations. So we can choose a group of k consecutive identical characters and we can remove them. So the operation can be performed as many number of times as possible until it is no longer possible. So suppose that we have been given this particular string, let's say geeks for geeks. So let us quickly copy this. So suppose this string has been given to us and k value along with it has been given as 2. So geeks for geeks has been given. So in this case, we can see that this is one consecutive character 2 and this is another. So the answer would be G, K, S, F, O, R and G, K, S. Let us see the answer for this. So we can see it is GKS, then FOR and then GKS. Let us now see another case. So let's say we have been given geeks, like let me just copy this example. Let us see this example as well to understand the problem better. So if we take the second example, that is this one, and have a look at it. So it is like G, E, E, G, S, then F, O, R, G, E, 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 K, S. Now in this case, if we will observe, so suppose k has been given as 2. So first of all, you can see that we can remove this part. We can also remove this. But what happens after you remove? So it becomes like G, G, then S, then F, O, R, then G, E, K, S. Now we can observe that this segment also is of k is equal to 2 length. So it is of 2 length and it is consecutive same characters. So I will remove this part as well. So it will be S, F, O, R, G, E, K, S. So it will be S, F, O, R, G, E, K, S. That is the final answer. So how can we do this? So for doing this, we can use the help of stack. We can take the help of stack for doing this particular question. How? So let us suppose that we have been given the string as G, E, E, K, S, F, O, R, G, E, E, K, S. So I can use a stack and implement this question normally. So initially in a stack, you will think that maybe I'll insert the characters, but no, I'll not insert the character. I'll also insert its frequency or the number of times that it is occurring consecutively. So what we will do here is we will first of all insert G, like we will insert in every for every element of the stack, we will first of all insert the character along with its frequency. Okay, that is what we are trying to do. So first of all, I'll insert G, and like if the stack is empty, then I will do this. So is the stack empty? Yes. So suppose I'm currently standing at this ith character. So is my stack empty? Yes. So I'll insert G with the frequency as 1. And after this part is done, so what we will do is we'll move to E. Then like K for this case, K for this problem is 2. Note that. So E, if I move to E, then is it empty? No. So I'll check it with the top character. So what is the topmost character? So if I see the top, like if I see the stack dot top, so actually the stack dot top is containing this particular pair. And if I want to check for the character, so if I do stack dot top dot first, so it will tell me that okay, the character is G. So is it equal to S of I? Is it equal to the ith character? No, it's not equal to the ith character. So in that case, I'll say that okay, I'm not going to increase the frequency. So in that case, what we can basically do is we can insert the new character as well, E along with its frequency as 1. Okay. Now what we will do is we will move to this E. The moment we move to this E, so again we check with the top character. So the top character is E. So are these two characters same? Yes, they are the same. Right? We can see that this character and this character is the same. So what would be the frequency? What would be the new frequency? So if I see the previous frequency, so the previous frequency of E was 1. Now if these characters are consecutive, if the ith character is also the same as the top character as the previous character, so that means that the frequency would increase and it would become what, 2. And now I'll check. So does this frequency 2 equal to the k? Yes, it is equal to the k. So in that case, I'll not be inserting this particular character. So I'll say that okay, the frequency I can reduce the frequency by 1. Okay, the frequency was 2, but now I'll reduce the frequency by 1 because I'm not going to insert this particular character. Apart from this, since the frequencies is still remaining, So I'll remove this E as well, right? So I will remove this as well. Like there is just one occurrence, the frequency is 1, so that means I'll remove one occurrence of this. One element from the top I'll remove, so I'll remove this part. I'll remove this from the stack, okay? Then what will happen, I'll move to the character K. So in this case, you can see how I have eliminated E. Now I move to K. So when I move to this character K, so is it equal to the top element? No. So in that case, I'll insert K comma 1 and it is not equal to the frequency. Now what I will do is I'll move to S. So is it equal to the top character? No. So in that case, I'll simply insert it with S comma 1. Then I move to F. The moment I move to F, so is it equal to the top character? No. So I'll insert F comma 1. Then what will happen? We move to O. O is not equal to the top character, so we'll insert what? We'll insert 0 comma 1 here. Then O comma 1, sorry. After this part is done, so what we will be doing is we'll be going further. So the next character is R. So we'll insert R comma 1 because it is not equal to the top character. Then we move to G, so we insert G comma 1. And after that, what we do is we again insert E comma 1. Then what happens after this? We will get what? We will get the same character, okay? Because now the top character, if I is pointing to the second E, if I is pointing to this E, okay? So it is equal to the top character. So in that case, the frequency of the top element of the stack is what? 1. If I add 1, this character is the same, so the frequency would increase, so the frequency becomes 2, which is equal to K. So in that case, what I will say is that first of all, I am not going to insert this ith character, so the frequency would actually reduce to 1, it will get reduced by 1. And then if the frequency is greater than 0, so that many top elements I'll be removing, because that those top elements would be the consecutive characters that are occurring k number of times. So in this case, frequency is 1, so I'll remove only one top element, so one element from the top, so I'll remove this element. And then my k, my pointer moves to this k, so k comma 1 I'll insert, then s comma 1 I'll insert. Then what will happen, I'll after this part is done, so my iteration would be done, and this is the situation in the stack. After this, I'll one by one keep on popping them out and store in an answer. So k will be stored, then s will be stored, then g will be stored, okay? So I'll pop out this, basically I'll be just storing the characters. I do not care much about the frequency, so I'll store G, I'll store R as well. After that I'll store O, then I'll store F, then I'll store S, then K, and then G. So one by one I'll keep on popping the elements out, and I'll keep on storing the top elements. Now is this my final answer that I was expected to give? No, the final answer actually is the reverse string, because in the stack you know that last in first out is there, so that is why I need to reverse this particular answer. So it would be GKS. So once I reverse it, so it would be GKS, then FOR, then GKS. That is what will happen. Now this is how we implement the first test case. Let us look at the second test case also, because it is also quite important. So let's quickly copy the second test case as well, so that we can do the dry run of it using the stack approach that we just discussed. So if this is the case that has been given to us, suppose, so how can we do this? So let's say that we have been given G, E, E, then G, then S, then F, O, R, then G, E, 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 K, then S. So how will we implement it here? So basically we will again have a stack, in which what we will be doing is, inside a stack we'll be storing the character along with its current frequency, okay? So first of all I come to G, okay, K value for this question is 2. So I come to G, so G comma 1 I'll insert, because the stack is currently empty. Then I come to E, so is it equal to the top element? No, so in that case I'll directly insert E comma 1. Now I come to this E, is it equal to the top element? Yes. So I'll say that, okay, now the frequency of the top element comes to be 2. Is it equal to K? Yes, it is equal to K. So I'm not going to insert this ith character, so that's why I'll reduce the frequency by 1, but still the frequency is greater than 0. So that means like this E is consecutive, right? This frequency was equal to 2, so that means it was equal to K. So one time I'm not inserting this second E that I'm getting, I'm not inserting it, so that's why the frequency reduces by 1, but still I need to remove the top elements one by one out until the frequency is greater than 0. So I'll mark the frequency decrease by 1, and then I'll remove this top element, okay? So that is how I'm doing it. Now after this my frequency becomes 0, so then I'll stop. Then I'll move to the next character. So the next character is G. Is it equal to the top element? Yes. As I mentioned, if you remove this part, so it becomes what? GG, right? GG and then S and the rest of the string. So now that means that you will be removing this part as well, and you can observe. Now what will happen? I will see that, okay, the characters are, the top character and the current ith character is the same. So in that case, the frequency would become what? The frequency would be nothing but 2. If the frequency becomes 2, which is equal to k, so that means I'll not insert this ith character. So that means the frequency I'll reduce by 1. Okay, I'll do frequency minus minus, and still frequency is greater than 0. So that means I'll remove it. I'll remove that much number of times till the time frequency is greater than 0. So frequency comes 0, and I'll remove this part. So that is how I'm skipping this. Okay, so that's how, like, first of all we had G E E G G S, where we removed the E part. Then these two G came together, so it was like G G S. So these two G's are also eliminated by using this stack approach. Then what happens? My pointer moves to this I moves to this S. So if the stack is empty, I'll simply insert S comma 1. Then I move to F. So is it equal to the top character? No. So I'll insert F comma 1. Okay. I move to O. Is it equal to the top character? No. So I'll insert 0 comma 1. Then I'll insert G comma 1, because if the ith character is G, then also it is not the same. If I move to E, so I'll insert E comma 1. Then what happens? I move to the next character. That is the second occurrence of E here. So if I move to this occurrence, so in that case I can say that the frequency of the top character is currently 1, and the ith character is also the same as the top character. So that means the frequency changes to 2. If the frequency changes to 2, so it is equal to k only. So I'll say that, okay, I'll not insert this ith element, so I'll reduce the frequency by 1. So frequency becomes 1, and I still like till the time frequency is greater than 0, so that many top elements I need to eliminate. So I'll eliminate this top element. Okay, then the frequency reduces to 0, so I'll stop removing the top elements out. Then I move to this E. So is it equal to the top element? No. So I'll insert E comma 1. Then I move to the K. So is it equal to the top element? No. So I'll insert K comma 1. Then I'll insert S comma 1. After this, I have iterated through all of the string, and all the characters that are there, that they must have been removed. So I'll one by one keep on popping out the stack. Like S will be removed. I'll just be bothered about the characters and not their frequency. So I'll remove S. Then I'll remove K. Then I'll remove E and store it in my answer. Then I'll have G as the top element. Then I'll have O. Then I'll have F, and then S. So is it the answer that I wanted? No. Basically, what I wanted was, I wanted my answer to be in reverse order, right? Because a stack implements the concept of last in first out. So what we will do is, we'll say that S, F, O, R, G, E, K, S is our final answer. So that is why we will, whatever answer we have stored from the stack, we'll reverse it and then return it. Now there's an edge case in this particular problem. Suppose the K value in this problem is equal to 1. So if the K value is equal to 1, so that means if there is one consecutive occurrence of a character, so you remove it. So let's say that if we have a character like geeks and we have K is equal to 1, so that means you will remove this, then you will remove this as well, then you will remove this, then you will remove this, then you will remove this. So this basically indicates that if the K is equal to 1, so you will simply return null. Otherwise you will implement this stack approach. So let us try and write the code for it. So what we will be doing here is, we will say that if K is equal to 1, okay, so that means like just one consecutive character has to be removed. Every consecutive character has to be removed. So that in that case the string would actually be null, and I can simply return the null without any calculations. Okay, after this part is done, so we can simply declare a stack which will consist of a pair. Let's say char comma int. Okay, let's name it as st. And after this, what we will do is, we'll iterate through the current string that we have. So I starts from 0, I is lesser than n, that, or I can say s dot size of the string. Then I'll do an I plus plus, and I will check. So I will check if the stack dot size is equal to 0, or I can check if the stack is empty. If the stack size is 0, that means that the stack is not having any element. So in that case, what I will, like, st is the name of the stack. So if in that case, I'll simply push I'll simply push the ith character along with 1, okay, because it is occurring one time. Otherwise I need to check, right? Else if it like, there can be some scenarios. So suppose if the top element, if if the stack dot top dot first, which is indicating about the about the character. So if the stack dot top dot first is not equal to the ith character, so that means that the ith character currently is coming for the first time. Its first consecutive occurrence is there. So that's why inside the stack, what I'll push is, I'll again push nothing but s of I comma 1. Okay, that is what I would do. Otherwise, if it is same, if the top character is equal to the ith character, so in that case, what will I do? I'll say that, let's calculate the frequency. So frequency will be nothing but st dot top, right? Frequency I can get using the st dot top dot second, which can tell me the frequency of the current character, and then whatever its frequency was, I'll add 1 to it. And after this part is done, so I'll also see that which character is there. So I'll say that char ch is equal to nothing but let's say st dot top. Okay, dot first, because it in the first part I'm storing the character. Okay, so now what I will say is I'll check that if this frequency, if this updated frequency is equal to, because the top character is the same as the ith character, so in that case the frequency would increase by 1. So if the frequency is equal to k, okay, so if the frequency is suppose if the frequency is not equal to k, so if the frequency is not equal to k, then I'll say that okay, inside my stack what I'll do is I'll say that stack dot push what the character along with the frequency, right, along with the updated frequency I'll push. Otherwise what I will do is, else I will say that I will first of all do a frequency minus minus, because that means if the frequency is equal to k, so that means the current stack top is containing the characters that is k consecutive. So first of all I'll not insert the current ith element, so that means one frequency, that is why I'm reducing, because I'm not inserting it inside the stack. Then what I'll say is that I'll say that while the frequency is greater than 0, till that point of time what I will simply do is I'll keep on popping it out. So simply what we will do is we'll say that stack dot pop, and then we will simply say that frequency minus minus. So we'll keep on decreasing the frequency until the frequency is greater than 0. Till that point of time we'll keep on popping out the top element of the stack. After we are done with this part, so we will simply say that we can have a string, let's say answer is equal to null, and we will simply iterate through the stack. So we will do what we will say that while the stack dot size is greater than 0, so till that point of time we need to extract the characters from the stack. So we'll simply say that answer plus is equal to nothing but stack dot top dot first. Okay, that is what we will do, and then we'll pop out the top elements one by one. Stack dot top dot first will give me the characters, and after this should I directly return the answer? No, I should not directly return the answer, because the stack implements the concept of last in first out, so the answer is getting stored in reverse order. So in that case I also need to reverse the answer. So REVE RSE, so I'll reverse this string answer dot begin comma answer dot end. Okay, so I'll simply reverse it and then I'll return it. So let's try and see if there is any error in this code. So it seems to work on the samples. Let us try and submit this approach as well. So you can see that in the very first go, our solution was able to pass all the test cases. And talking about the time complexity of this code, so it will be order of n, and the space complexity would also be order of n, because we are using the stack solution. Thank you.